All right, so today we're going to learn about a very important concept in database. If you allow me to share my presentation slides so that you can start, it's going to be a short one today. I don't want to give you so much content today. Today's going to be a short one because I want you guys to enjoy Easter. For all my Christian friends, for all our Muslim friends, they refuse to invite us for the Ramadan. So I don't know if you're going to invite them for the Easter, but no, Christian will. Okay, I don't want to go that way, but you can invite anyone, right? Now, okay, I believe my presentation slide is visible on your end. Okay, I don't know, it is taking long. There. All right, there it is. Great. All right, welcome to database design module week 6, right? Now, yeah, I know today we're gonna learn about week 6, but just to just a heads up, you can do the assignment up to week 7, okay? So the classes that you've had so far, you can do the assignment up to week 7. Feel free to do them. But if you're not sure, you can always go back to the recordings, just binge watch or watch. Make sure you understand, and then you can always do the assignment. Yeah, and now what you're going to learn today at the core of this lesson, you learn how to do the following. Number one, you're going to understand and apply normalization technique to reduce redundancy and optimize the database structure for efficiency. Number two, we're also going to learn the concept and rules of the first, second, and third normal forms to ensure data integrity and minimize anomalies. Finally, we're also going to apply database normalization to practical example demonstrating how to avoid update, insert, and delete anomalies. Great. So first things first, let's start by learning what exactly is normalization. I know most of you know this term, normalization. So what do you think is normalization according to your own terms? Just try, give it a try. I'm going to read the comments. So just try, don't think hard. Just tell me, what do you think uh, normalization means? When someone asks you, what do you think normalization is? How would you define normalization in your own terms? Yeah, let me read your comments. Reduce all anomalies. Thank you, Gospel. That's impressive. Then it says normalizing. Just a Kenyan way of describing things. All right. Um, Chinedu, make it normal. All right. Okay. Make it a habit. Okay. Make it a habit. Darlene, write data to DB reduce redundancy. Hey, Mr. Felix, Mr. Officer, yes, sorry. Dami says to make accurate across a field. Hey, Stephen says standardizing. Hey, you guys are giving me some new terms here. Standardize of data, organization of data, standardize, remove dependency. Lillian. Hey. Wait, they make something organized. Someone. All right. Sylvia, making something uniform. All right. Thank you for all the participation. But let me now give you like an official definition, and then we can see how we can summarize it. All right. So normalization is a systematic approach to decompose. So by decompose, it means break down tables to eliminate what we call data redundancy, aka repetition, and undesirable characteristics like insertion anomaly in DBMS, update anomaly in DBMS, and delete anomalies. I know, you know what? This definition is too long. Let me give you a shorter one. If someone ever asks you like what normalization is, just tell them it's the process of organizing data within a database to eliminate data anomalies. Keep it simple. Just leave this long definition. Just tell them it's the process of organizing data within a database to eliminate data anomalies. Isn't that simple? Or you want me to write down? Okay, let's write. Now, it's the process of organizing data within a database to eliminate data anomalies. So I know you're asking yourself, what are these anomalies that you're telling us about? It's simple, redundancy. Keep it short. Okay, we can go to the next topic. Okay, next subtopic. Now, the next subtopic is about why normalization is important. So if you allow me to switch a little bit to a different tab, I want to speak on these I want to speak on these reasons why normalization is important. So number one, we say it reduces redundancy. As I've said, redundancy is what? Repetition, right? So I have the Excel draw here. I just learned this new tool, and I also have Gerald taught me. Now, we've said, hey, okay, please don't embarrass me. I'm doing a live class. Anyway, I'm kidding. Okay, not that one. Hey, they started embarrassing me. Okay, not that one. Hey, Gerald, I thought I'd mastered the art of writing this thing.
Z
Is
Zaplon, you actually use
hmm?
the A.
Oh, the A. You see,
Yes.
okay. There. Hey, there I was excited to teach them a new tool. No problem, no problem. All right, so we've said data. Okay, yeah, there it is, integrity. And now, when you said, okay, not data integrity, I'm even way ahead. Reduce redundancy. Hey, I need some coffee. All right, now with redundancy. So redundancy, you said, is when the same information is stored multiple times. And a good way of avoiding this is splitting our data into smaller tables, right? Another key importance of normalization of why we need it is improve what we call query performance. So what exactly do I mean by, okay, I'm gonna leave this tool. Improve, okay, yeah, thank you. Improve query performance. So what do I mean by improve query performance? Okay, by query performance, you can perform faster query execution on smaller tables that have undergone normalization. You'll find that if a table has normalization, it is easy to fetch data and also maybe update, delete. You can perform the CRUD, okay? So the CRUD is create, read, update, delete. It's simple when a table has been normalized. Now, another key importance of why we need normalization, I can say, is because we want to minimize what you call updates anomalies, right? So I know most of you have seen a scenario where you're trying to update data in a table, and then when you try, it returns an error like cannot update this kind of data, or maybe it's a consistency error, things like that. So what it means by having normalization, when the table is normalized, you can easily update data without affecting other records, just like that. And then another one is enhanced data integrity. I know everyone has met this, everyone has come across this error, right? The data integrity part, where when you're trying to delete maybe a certain record, it tells you it depends with another table. So you need to go and delete that table first and then come to this one. So by having normalization, it ensures that data remain consistent and accurate. So we can say here data integrity, like that. So these are the four reasons I came across on why we need normalization. So if you're writing, you can write, then give them your own description there. So another thing is actually what causes the need for normalization? So I'll tell you what. Now, if a table is not properly normalized and has data redundancy, it will not only take up extra storage space, but also make it difficult to handle and update the database. Okay, there are several factors that drive the need for normalization, from data redundancy, as we've described, to difficulty in managing relationship. So number one, it could be what causes the need for normalization. We've seen the benefits, right? So I'll just leave this one here and then drag it there. So what causes the need? I'll fix that one. I'll have it here. So what causes the need is insertion, deletion, deletion and updates anomalies like that. Another one that we need. Okay, what causes the need for this is difficulty in managing relationship. And another one could be what you call partial and transitive dependency. We're going to learn about this later. So don't worry about them. Now, we have the insertion, deletion, and update anomalies. Also, difficulty in managing relationship. I know most of you are facing a lot of challenges when it comes to like describing the relationship between the tables that I told you to create in the group work assignment, right? So you'll find that when the relationship is difficult, sometimes it need you might find that it becomes more challenging to maintain a complex relationship in a normalized structure. So if your tables are not kind of relating to each other, it becomes difficult to manage them. And then this, as it goes, insertion, deletion, update anomalies, when you're trying to update data, but any form of change in data can lead to errors or inconsistency in other tables, if not handled carefully. So we've covered why we need normalization and what are the importance of normalization. So what are the different types of normalization? Let's come back to our slides. Now, these are the different types of normalization, but our main area of focus will be the first three. And then the other ones, it's good to know them, but in rare case, you'll ever need them, okay? Just know them, they exist, yes, but you'll never be tested on them, on how to use them. Mostly, you're usually tested on the first, second, and third there. Now, let's learn about the first normal form. So we have the first normal form, the second normal form, the third normal form, the BCNF, the fourth normal form, and the fifth normal form. So what is the first normal form? So this is the most simplest one. This normalization level ensures that each column in your data contains only atomic values. Later on, we are going to see what I mean by atomic values. Only single values in a column. So atomic values in the context means that each entry in a column is indivisible. It's like saying that each cell in a spreadsheet. I know everyone has used the spreadsheet or the Excel, the Microsoft Excel. You should just have one piece of information in each cell. So with first normal form, it ensures atomicity of data with each column cell containing only a single value and each column having unique names. Nice one, Kingston. Most of us used Excel, but not of us Excel. That's a good joke. Now the second normal form, it eliminates what we call a partial dependency by ensuring that non-key attributes depend only on the primary key. What this means in essence is that there should be a direct relationship between each column and the primary key and not between other columns. We're going to see how, all right? Using the examples. I know right now I'm just seeing the theory part just to finish the theory so that we go to the hands-on. Now with that normal form, it just builds upon the second normal form, but now it removes the transitive dependency by ensuring that non-key attributes depend only on the primary key. This level of normalization builds upon 2NF. And then the BCNF, I couldn't write the whole word, but so I just wrote the initial. So what it means is boys hyphen code normal form. Okay, just pronounce it in your own, how you pronounce it. Let me just tell you how it is written. So this is the term for that BA, boys code normal form. So BCNF there. So boys code normal form. I don't know if that's how it is pronounced, but according to how my English teacher taught me, I think it's boys code normal form. All right, I might be wrong though. So with the boys code normal form, BCNF, this is more strict version of 3NF that addresses additional anomalies. At this normalization level, every determinant is a candidate key. And then we have the fourth normal form. This is a normalization level that builds on BCNF by dealing with multi-valued dependency, complex relationship. That is what it means. So all these, they are building upon each other. So we have first normal form. So with second normal form, it builds upon the first normal form. So second normal form depends on that normal form. By the way, since we started learning database, we've been applying normalization. It's only that you did not know that what you are doing is actually normalization. You're gonna see how. And then we have BCNF, and then the fourth normal form, and then the final one, fifth normal form. Now with this one, it's usually used to manage like complex joins when your database has complex join. So to ensure that you're able to manage those complex joins, you have to have this fifth normal form. So fifth normal form is the highest normalization level that addresses join dependencies. It is used in a specific scenario to further minimize redundancy by breaking a table into smaller tables. Okay, let's leave all this type of normal form. Let's focus on the first three. Now, let's go with the first one. Now, with the first one, we have what we call rules. So the first normal form, as I said, the table should be what? For a table to be in the first normal form, it should follow the following rules. It should only have a single value or atomic value attribute column. All the columns in a table should have unique names, and the order in which the data is stored should not matter. Let's see what I mean by, I'll come to my Xalitro. Now that I've known how it works, I want to draw a small table. So I need 4 columns. That is 1. Okay, I need another one. 2, 3. Okay, don't worry how they look. I'm just trying it out for the first time. There. These lines are not straight. I need a ruler. Tara, do you have a ruler here? Anyway, I'm kidding. So we have the ID, title, and then maybe we can have, I'm trying to create like a simple table. Author, um, Jonah. Okay, I need another one. Borrowed by. Okay, there. So this is how usually the table looks like, right? So we have there another one there. So one more final one there, like that. This is how I usually design the table. So we'll have here like ID1, and then you can say the title. Just tell me your favorite books. Which book or which books have you been reading recently? Any book that you've been reading recently. Just tell me the name. Let me tell you one that I've been reading. Nearly all men in Nigeria, not Nigeria, sorry, Lagos, are mad. Jared, have you read this book?
Uh,
Jared,
Not yet, Zablon. I think I'm going to add it to my bucket list of books that I need to read. It must be very interesting. I see a lot of
hey, yeah, yeah,
people
yeah.
know it, eh?
Let me tell you, this book, from the preface until to the end, is just
Yes.
laughter.
Oh my.
The other is called Damilare. Damilare Kuku. I don't know. I'll just say it's contemporary. And then maybe I'm the one who has borrowed this book. Also, Gerard has borrowed this book. Okay, there. There. That's the other. So we have this book, right? You can see here. Okay, let me have another one. Let me see. Which other book have I been reading? Oh, Confession of Nairobi Men. Okay, for those who love one, please read this book. If you love one about men, go and get this book. Yeah, there's so much juice in this. Also, there's one for women. Go and get it. The other is called Joan. I don't know if to say it's fantasy. And maybe I can say who has borrowed this book. Let me read your names. Okay. Simon and Joseph. Joseph be making a lot of noise in the WhatsApp group. Let me just write you here because I know your name. Hi, we have another book. Okay, so what I'm trying to draw, I'm just drawing like how you create a table in a database. This is how the table look like, right? Before we come to our SQL workbench. So another book, okay. Tell me your books. I'm out of books. Poor Dad, Rich Dad. Hey, no, Echoes of War is not a book. Is there a book about Echoes of War? The Secret Lives of Baby Segi's Wife. I've heard of this book, Jesus the Savior. Hey, um, Deep Work the Pearl, Richest Man in Babylon about saving nice one, Unplugged. Hey, this is for, hey, you guys are reading nice books, eh? Unplugged by Jacob. This one is about what? Masculinity, positive masculinity. Now, Who has borrowed this book now? Stephen. This is a counterpart, a friend to Joseph, and Joseph also. Okay, I'll stop at that now, but you get the concept, right? So if I design the table in our SQL workbench, already we have violated what we call the first NF, 1NF, the first normal form. Reason being, you see this column has what? Multiple values. And we said a column should only hold single values, not multiple. All right. So what would be the solution? In the first NF, we create a separate table for the borrowers and link them with the book table. This table can either be linked using a what? The foreign key in the borrower's table or a separate linking table. The foreign key in the borrower's table approach involves adding a foreign key columns to the borrower's table that references the primary key of the books table. This will enforce the relationship between the tables, ensuring data consistency. So let's see how we can achieve first NF. So if you're following along, you can open MySQL Workbench. I've opened mine as well. There it is. So what I want to design is the same way I've drawn here. If you're able to come up with this table quickly, do it. Now, so I'll come here and then, do I have a library database or I need one? Okay. Zoom in. So create database. I'll call it lib, short form of library. And then, okay, I'll create this one first. There it is, refresh. You see it's here. So I'll change this and write use like that. Come to the next line. All right, let's create the table now. So create table. I'll call it books. Okay, and then come to the next line. I want the IDs to, okay, I want to have book ID. And the data type should be an integer. Okay. Another one constraint that I want to pass primary key. Another one is auto increment. This one being, I don't want to write the IDs. I want the server to write it for me. Now, the title, varchar 50. We have outer, also varchar 50. Another thing, the journal. Okay, yeah, I can leave it like that. So what are we trying to achieve? We're trying to see how we can split this table to become two in order for us to achieve what we call the first NF. Because we don't want to store multiple values in a single column like this. Right, so if you've written that, just come downwards. Okay, go press enter, go to the next line, and then create another table. Create table, call it the borrowers table. So these are the books borrowers table. Okay, this name is too long. Like that, and then borrower ID is gonna be an integer. Constraint primary key, then auto go to the next line. We have the name of the person who borrowed. And then book ID is going to be an integer. So we create a foreign key. Like that. We pass that it references. The books table. This column. There. So we can close it like that. So that's how the two table will look like. So if you're drawing, not drawing, but if you're writing, please write. If you're writing in your books, also write quickly. If you're following along, let's take the shortest time to have the same commands in your workbench as me. All right. If you're done, just let me know. Or you want me to copy the code? Okay. There. So everyone has created the lib database, right? Now, if I copy here, there, I've pasted. There it is. I've shared. All right. So we are good, right? Now we can continue. So we can execute all this because we've created the table. This one is there for us table. And then this is the table. The ones that I've been telling them to repeat the assignment. Have you seen how I'm writing my comments? Not like this. If you write like this is wrong. As you can see, even the server is telling me that this cannot be executed because it's not a what? It's not an SQL statement. So just make sure you have some space um, between the two hyphens or the two minuses and what's up with this one now? Books. There. So books table, and then we have the borrowers table. So once you execute, a thing will be created in the library, and then we can insert data. So let's execute, and then we get all the green checks. We can comment this, or I can open a new page. Okay. The reason why we comment is because you don't want the server to read the same commands, because if it executes the same commands, definitely it's gonna throw an error. So we can insert here, right? Insert. So in books, we are inserting the title, the author, and the genre. Values, open a bracket, then start specifying. And then the other is called Damilare. It's just an example. And then the genre we said is, we can write contemporary. Close it like that. Let's create another one. The other one will be what? Purple hibiscus. The other is Adichie. Can write it as fantasy. Okay, I'll create two books for now, and then we're gonna populate it with data. So that is it. If you want me to copy this, I'll just copy and then send it your way. There, I've shared it. So you can execute. Okay, we have an error. So it says the data is too long. Hey, this is more than 50. The title. All right, looks like nearly all men is too long. Let me try nearly all. Okay, there we have it. So it has inserted 2 rows and 0 duplicates. So if I try to retrieve, select all from books there. So we have nearly all men in Lagos, Ahmad, and then the other is Damilare. The genre is urban. You can change it to any genre. I'm just using it as an example. So let's insert another one in the borrowers table. So insert. Okay, I'll just open a new page. Use lib insert into borrowers table. So which columns do we want to insert data? We have the name of the borrower and then the book ID. So just that. So it's name and then the book ID. And then here say values. So Zablon. I'll go with book ID 1. Gerald.
Yes,
also go with,
I didn't catch that.
oh no, I'm just writing your name here. That you borrowed that book. Yes. Let's execute. So once we execute, you get this. Now, if I try to retrieve, there we have it. So we have the borrower ID, the name, and the book ID. You can always continue adding more data. Now, have you all understood the concept about 1NF, the first normal form? At this point landed, yeah, you can just react with a thumbs up if you've understood. Yeah, because it's something familiar. You've been doing this all this time. It's only that you did not know what you're doing. You're achieving what you call the first normal form. Anyone who's lost? So we are good on this. We go to the second one. All right. So you can always insert more data, but I can see quite a number of people have reacted with a thumbs up. That means you've all understood. Now, let's go with hey, the, someone is saying starting from the create table. We said this is how you create the table, right? So create table books. These are the columns that you want. You can see the columns are here. Column, row, column. This is column. This is a column. This is a column. This is a row. This is a row. Now, if you execute this, because I shared this code, this table will be created. And then to insert data into this table, you write insert into books. This is the name of the table. You specify which column do you want to insert data into, right? So you specify the values, nearly all men in Lagos, Ahmad. The author is Damilare Kuku. Jonah is contemporary or urban. And then we insert multiple books, not just these two, to try. And then you try to retrieve everything from this table and see how it's organized, right? Now, instead of having another column here that has the names of the borrowers, maybe two people have borrowed this book, or three or multiple. Instead of having a column that stores the name of multiple people who have borrowed a certain book, you just create a new book that will be used specifically, okay, to store the name of the borrowers. And then with that, you would have achieved what you call the first normal form. With that, let's go to the second normal form. Okay. So with the second normal form, in fact, is another easy. Okay, it's more simple. It's simple because you'll find that you've already done it, only that you did not know that what you're doing, you are trying to achieve the first, the second, and third. Now, oh, hey, I've gone to the third. Okay, the second, where's the second one? Third, oh, there. Now, with the second normal form, we say for a table to be in the second normal form, it should be in the first normal form, which you've done, and it should not have what you call partial dependency. All right. This one, I'll use a simple example. Very simple. Let me try to think of one quickly. See, now let's come here to Exalidraw. Hey, God bless the one who created this tool. Now, so let's try to design a new table. I'll create that like that. Like that. Okay. The only feature I'll recommend, they add a ruler. Yeah, that way. Or it's my eyes. No, I see straight. Hey. Hey. Like that. So we have maybe a customer ID. We have the store ID. Store location. Nairobi. Lagos. I was about to write Johannesburg, and then I remember I don't know how it is written, so I said, hey, let me not embarrass myself, Gerald. All right. So store ID, D1, maybe D2. D3. Customer ID 1, 2, 3. Now, so we have we call this, maybe let's call this table the location table, right? So the location table possesses what you call a composite key, the customer ID, this one, and also the store ID, this one. The non-key attribute is this one. So if you ever hear a term non-key, it means this key, a key that is not the primary key. It's simple like that. Non-key attribute is the key that a key that is not a primary key. So in this case, store location only depends on store ID, which is part of the primary key. Hence, the table does not fulfill the second normal form. To bring the table to second normal form, you need to split the table into two parts. So if we were to split this table into two parts, how would we split it? Just try to give me a guess. Just give me a wild guess. I'll read your comments. Yeah. Have a table to store location. Yes, Dennis, that's actually correct. So I'm saying if you are told to split this table into two tables, how would you have have divided it? So it's simple. We can have our table. Is there a way to highlight? Okay, I don't see it. Now, you see these two. We can create a table using these two and another one to store these two. Reason being, we don't want this store location to depend on this key. Okay, so we're trying to split it to have two tables, one for location and another one for customer. Simple like that. Yeah, so if you're following along, you can go and create. Now, if you were to go back to our previous example, the one that we had created before the library, right? And let's see. Let me try to see how we can organize it. All right, I know you all remember this, right? Last week we covered various type of relationships, right? So I want to see another. I want to tell you, or I want to show you another way you can achieve what you call second normal form. So this was the first one. You split this table into two. Another way. Do you guys remember the types of relationship that we covered last week? Yes, please. Now, if you can tell me the type of relationship, just say it here. One to many. Thank you, Dami. Simon, nice one. One to one. Also, Sylvia, perfect. Victor, amazing. Isaac, Eunice, Sharon, Moses, Pauline, thank you. Now that you've mentioned the many to many, we can introduce. Okay, let's say we want to link this table to record borrowings. Okay, so instead, I'm trying to see how we can structure that table. Okay. So in this books table, can we add another column maybe to say borrow ID? That one will make our table way quite hard to manage. So what if we try to use the many-to-many relationship? So with the many-to-many relationship, we can create a many-to-many relationship between books and borrowers to achieve the second normal form. So we can introduce a new one. We can say, here, let me create a new one. So we can create a new table. Let's call this table. use, create, table. This is how you can achieve the second normal form table using the many-to-many. And another way is just splitting the table. Create table, books, borrowing table, and then here you can have the borrowing ID. It's an integer. Oops, it's a primary key. Auto increment. And then we can introduce two new columns, book ID, integer, not now, borrow ID. It's also an integer. I'll pass another constraint here, not now. I can also introduce another one. Okay, no. So we can write here foreign key. Book ID, references, references books, book ID. Another one. So to achieve the many-to-many, foreign key, borrow ID, references, this table, this column. All right, there's something that I'm missing. If you see that error, okay, let me just check. Where am I missing here? Comma, like that. So we've introduced a new table to create a many-to-many relationship between the people who are borrowing the books information, the people who are borrowing, and also we've introduced another table to create a many-to-many, meaning many people can borrow the same book, right? Another concept I can give you around this is, do you remember the example I used last week, where a student can register for multiple courses and a class can have multiple students? It's the same thing. So with the many-to-many, what you're doing actually is you're achieving what you call the second normal form. It's that simple. Yeah, so you can create this. I hope I've written everything correct. Let's see if, yeah, there it is. So we can insert data. Insert into books borrowing, and then book ID, comma, borrow ID, values. You can just write here book ID 1, borrow ID 1. Now, if I retrieve, select all from borrowing, there we have it. So as you can see, this is what you call the many-to-many. You can always try it with different kinds of data. Yeah. So with this, we've achieved what? We've achieved what you call the second normal form. Oh, yeah, I missed not null, but what this means is, okay, I passed a different constraint, but you can use the alter command to change or modify the column name or the column constraint, but as long as you'll fill it with data, yeah. So here instead, I forgot to add the not now. Thank you. Now, we've learned about the many-to-many relationship. Another example I can give you with the many-to-many is where we have like a student enrolling in multiple courses. Are we good with a second normal form? Or I copy the code, all right. There, I've shared the code, the right code, yeah, there. Okay, and QA, I'm not able to go to the QA, but I'll try. I've shared it. Now, that is all about the second normal form. So let's understand actually what we've done. For a table to be in second normal form, it should be in the first normal form and should not have a partial dependency. By partial dependency is where an unkey column, depending on a key column, depending on another column, which is not an unkey. Is that example sufficient? We go to the third normal form. Yeah, I've shared the code. All right, I see people are saying repeat the second normal form and what it means. So, okay, so as we described before, the second normal form, it builds upon 1NF, the first normal form, by ensuring there are no partial dependency on a primary key. In simpler terms, all non-key attribute must depend on the entire primary key and not just part of it. From the first normal form, that we implemented, we already had two separate tables, right? We had the book and the borrowers. Right? Yes. Now, okay. Yeah, I'm trying to see. Okay, I'm trying to read your comments so that I know how to describe what you're facing. Is second code on 1F, repeat the explanation of 2NF. So with 2NF, it means, okay, first know that it builds upon 1F by ensuring there are no partial dependency on a primary key. So by partial dependencies, when I give you like this table, I said, instead of this one, depending on this one, because it's a non-key attribute, right? So you should create another table called store location, which will have its own ID and the store location like that. Let's see. Let's learn about the third normal form as we summarize this now. Now, with that normal form, it builds upon 2NF by eliminating a transitive dependency. A transitive dependency occurs when a non-key attribute depends on another non-key attribute, which in turn depends on the primary key. It basically takes the meaning from transitive law. All right. Let's say, for example, we add due date to this column here. I don't know if this one can extend. All right, I just introduce a new column here. Due date. So I've introduced a new column in the books table, right? So the due date depends on what? The book's borrowing ID, right? It depends on the people who have borrowed India. Now, with that, with the book borrowing ID from the book's borrowing table, the borrowing ID in turn depends on the book ID, the primary key of the book's table. The implication of this table is that due date relies on an intermediate non-key attribute, book borrowing, instead of directly depending on the primary key, book ID. This violates the 3NF. Okay, so we can move the due date column to the most appropriate table by updating the book's borrowing table to include the due date and the return date columns here in this table that we created. Where is it? This one. So we just add new column here. Borrowed date. We can say this one is a date. And then it's supposed to be that way. Another one we can say is due date. I'm just adding new columns to see how we can achieve the 3NF. Like that. Let me copy this code, send it your way. There, I've copied it. There. So by eliminating, by placing the due date column in the book borrowing table, we have successfully eliminated what we call the transitive dependency. What this means is that the due date now directly depends on the combined relationship between the book ID and the borrower ID. In this context, the book ID and the borrower ID are acting as a composite foreign key, which together form the primary key of the book's borrowing ID. Right, if I come here to the slides, so the third normal form, it's supposed to be third. I forgot to add. Now, the table is said to be in that normal form, and it satisfies the first normal form and the second normal form, and it doesn't have what we call transitive dependency. It's that simple. Yeah, so we've learned the first, the second, and the third, and now we go to the the checkpoint questions. Maybe can I get someone to read for us the checkpoint question? and then we can finalize this. Yeah, as I said, let me see. Today's class is gonna be a short one. Evelyn, yeah, go on. Hey, Evelyn has gone silent on us. Evelyn has ghosted the mic. Let's see someone else. Nabat.
Hello, can you hear me?
Yes, you're audible. Go on. Nabat.
Hello, can you hear me? Yes?
Yeah, yes, I can hear you.
Okay. So I read the questions. Question 1 says, why do we need numerization in DBMS?
Yeah. Why do we just type in the comments and then I'll read your comments. So I'll check the comments. Yeah, I can see Margaret, Lucy, reduce redundancy. Okay, it's Francis, Kiragu, Keshian. Okay, very unique name. Ian, reduce redundancy. Zulu says remove dependencies to avoid no anomalies. Michael, nice one. Read the second one.
Number 2 says, what are the different normal forms in DBMS?
Yes. So what are the different norms? What are the different types of normal form in DBMS? So we've said this, which and which one now? Wow. Dummy, nice one. Eddie Minor, perfect. Edwin, amazing. Sam, perfect. All right. Now the final one.
Final one, what are non-key attribute in a table?
Yeah, simple one. What are non-key attributes in a table? Yes, Lucy Were, perfect. Yes, also John, amazing. Catherine, amazing. Sumaya, amazing. Keys that are not PK. So yes, I can see we've grasped like the content for the first session. It's simple. Once you understand like how the relationship work in database, it's simple to have this normalization. You don't need to actually ensure that there's normalization. Once you start using the relationship and you know this is the many to many, by using the many to many, you know you're doing what? You're achieving the second normal form. By having a one-to-one relationship, you know you're achieving what? The first normal form. You're splitting the tables into multiple tables, right? And then in that normal form, instead of having a certain column, depending on a column that, okay, instead of having a column that depends on another table that do not have relationship between the table that the column is in, you're creating, you're supposed to create a column in a table where there is relationship between the table you want to reference from. Yes. So let's get a lady to read for us, and then I'll tell you what I want to tell you. And then Gerard, I'm gonna allow Gerard to take in the questions, and then we can call it a day. I allow you guys to go and enjoy for Easter. All right. So yes, I don't know. Today is when Jesus washed Judas' feet, right? Okay, I can't remember. I need to go and read the Bible. I say I don't remember. Is it today when Jesus washed his disciples' feet? I think it's today. Yes. And then tomorrow is when he gets crucified. All right. Yes. Now a lady. A lady to read for us. Evelyn. Evelyn, your mic is working now. Read for us.
Morning, everyone.
Morning.
Okay. The key takeaways. Number one, by identifying entities and relationships early, you can structure your database to avoid redundant and inconsistent data. Should I read all of them?
Yes, please.
Okay. The second one, applying normalization techniques such as the first normal form, the second normal form, third normal form, helps eliminate data redundancy and ensures data is logically and efficiently stored, reducing anomalies. The third one, in first normal form, we eliminate repeating groups and ensure that each column contains only atomic values. The fourth point, second normal form builds upon first normal form by ensuring that non-key attributes are fully dependent on the entire primary key. Then the last, in third normal form, we ensure that non-key attributes are only dependent on the primary key, eliminating transitive dependencies. Yes.
All right. Let's clap for Nabat and Evelyn. Impressive. Now I've shared the slides link so you can access the slides. Yeah, so if you're watching the recording, this is where I end the class and then taking the question. I know you have a lot of questions, so Gerald will take the best 5 and then we call it a day, right? So meanwhile, 5 minutes break. I take coffee quickly and then come back. So I don't know if this one is visible on your. All right, I'm back now. Today also we don't have a lab work. Yeah. I don't want to give you guys a lot of chat this holiday. I want you to enjoy the holiday. Yeah, I know last week I said I was gonna show you how to do Docker, but I couldn't manage to. Okay, I don't know. Let me see what I have, and then see if it's something you want to see to have the code, and then try it on your end. But don't put pressure if you don't have on yourself. If you don't have the Docker, again, I said you don't have to install Docker because it uses a lot of memory in your computer. So if you don't have sufficient memory in your computer, please don't install it. Otherwise, it's gonna give you a hard time to control it. Now, let me see. Let me see if I can get Docker. So I'm gonna start the Docker. I believe I'm still sharing my screen. So that's how Docker looks like in Windows, but in Linux it's different. So I'll open my CMD and then go to where I have all the database. All right. My screen is still visible, right, Gerard?
Yes, we can see.
All right. So I have what you call an image. It is, let me open my PS. So this is how Docker looks like. So I've written a small, what you call YAML, a YAML script to create my SQL. And then this is how I want the data to be. So I've created create table users, ID, name, email, simple data. Now, once I run the Docker, and then you're going to ask me things around Docker after I complete running it. So Docker compose. So it's pulling the image from MySQL and Admina there. So once it's done, let me reduce that. We'll just give it like 2 minutes, depending on how fast your internet is. Meanwhile, Gerard can check my message, the WhatsApp.
I've shared it, Zablon, on the chat.
All right, cool. If it works, perfect. If it doesn't work, I'll still write for you guys a nice script that will create it next week as we cover migration. My internet is unstable. Oh. Okay, it's taking too much time. It's almost done. I'll close my SQL Workbench because I'm not using it again. Okay, it is done. Let me just confirm. Not yet. Oh, there. Yeah. So once you see this, that means it's now ready. So we can test one more time, or I can write docker ps to just see if it's there. So that means MySQL is running and also the adminer. Let me try to open a new port. So there it is. So this is Docker trying to run MySQL. So here, so you can always try it with SQLite, Postgres, Oracle, or MS SQL. So all the commands we've taught you from week 1 up to the week that you're in, you can test them with these other ones. The Postgres, SQLite, MariaDB, and Oracle, they work the same. So with the server, I'll write here MySQL. Okay, root. My password, I like keeping short. I think it's sample DB. Let's try. There. So I've logged in, right? Now you can see our users table is here. So if I select all the users, is Alice, Bob, Charlie. I'm sorry guys, I know it's advanced, but I just want to make sure that at least you're familiar with these things. So if you're interested, you can always go and learn. Okay. So if you're interested with this, just go and learn. If you've been asking yourself how to maybe run MySQL using a web UI, this is one way. So if I want to create another table here, I can just come and call this table Easter. And then right here, I'll just pick an engine, say InnoDB, save at line 3. Okay, let me pass in some new things here. Let's see, int option auto increment. Their name, it's a variant char. Let's see if it will create 255. Save. There, table has been created, right? Now, we have the table Easter and table. This one. If I want to add a new item, I can just create there. Jesus washed disciples' feet. Okay, I don't know what I've been writing, but you get the point, right? So you can use the web UI to create to work with MySQL. This is another way. Yes, so there it is, Jesus. You can also edit it. Judas Iscariot. I really need to go to church. Hey, there it is. So yeah, I've shown you a new thing. So if you're interested, let me know if you want the code. I can share it with you as long as you have Docker. But if you don't have Docker, don't put a lot of pressure on yourself. You learn it as you advance. Thank you so much. Gerald, you can take the question and I'm going to stop the recording. If you're watching the recording, this is where the class ends. Where it is. Stop sharing.